Welcome everyone to the PARC Forum. My name's Stuart Card. Today's forum is the 14th talk in our special speaker series on going beyond Web 2.0, the power of the web for connecting people, collaboratively creating knowledge, enabling enterprises to use social software tools effectively, and so on. Before I introduce today's speaker, I want to let you know that the previous talks are available online at July 2005, he co-founded Metaweb Technologies. Prior to joining Metaweb, John was CTO of Tell Me Networks Incorporated, where he's responsible for the development and operation of the world's largest voice XML network, handling over 2 billion voice transactions per year. Microsoft acquired it in 2007. Prior to Tell Me, John was the chief technologist of Netscape, AOL's web browsing group. Throughout his career, John has contributed extensively to industry's internet standards and protocols, including HTTP, SSL, and RDF. And he worked for a while at one of my favorite companies, General Magic. Metaweb Technologies has created quite a bit of excitement and anticipation, partly because it's a spin-off of Applied Minds, a company created by Danny Hillis, who did Thinking Machines and worked at Disney Imagineering. These guys have a grand vision of organizing and making computational the knowledge of everything. Tim O'Reilly calls it building synapses for the global brain. So can they actually do this? Until recently, Metaweb Technologies has been in stealth mode. So this afternoon, you're going to get a treat. One of the first public peeks, and by the CTO and co-founder himself, at what these very creative people are up to. So without further delay, I give you one of the moving forces behind the new social semantic web, Giannandrea.
Thanks, Jim. It's too kind. Thanks, Stuart. That was too kind, I think, especially since I think we're at sort of Web 0.2, maybe. So I'm going to talk today for a little while about Freebase, which is a little project that we've been working on at my company, Metaweb Technologies. I have a bunch of prepared remarks, and then I'm going to take questions at the end. So today I'm going to cover what is Freebase exactly. There's a lot of ideas about what Freebase might be. I'm going to tackle the question of what problem are we trying to solve, or what might it be good for. I'm definitely going to talk about what Freebase is not, because that's a very important part of what we're doing. And then I'll give you some examples using Freebase, and I'll take your questions. It's a privilege to be here talking about this, but it's even more of a privilege to work on this project, which I think is potentially very significant if we get it right. And I'm very convinced that if we don't get this right, then somebody else will. That if we're here 5 years from now, somebody will have done this, and it will be of some import. So this is freebase.com. If you went to freebase.com today, this is what you would see. And it's a little hard to understand. There's a lot of stuff there. It's a very deep website. And so I'm going to take you through basically what it is and what it's doing. And then I hope some of you will visit the site and try and interact with it. So very simply put, Freebase is a community-built, freely available database of knowledge. So that sounds very pithy and quite reasonable. And I'm going to take you through these three things in order. In reverse order. So first of all, I'm going to talk about what we mean by a database of knowledge, because that's quite a mouthful, and it can mean a lot of different things to a lot of different people. Mostly what that means for us in Freebase is these things we call topics. Topics are machine representations of ideas, concepts. So here's three example topics: the Colosseum in Rome, a swell new digital camera from Canon, and the Laughing Cow cream cheese, which is very good if you've never tried it. These are the kinds of things that you might call common sense. We all know what they are, and there's millions of them. And yet our computers and our machines and our systems don't know how to talk about them, and we'll get to that later. So what we do is we've made a big list of these things, and we've reconciled them all together So we only have one copy of San Francisco, one copy of PARC, and so on and so forth. We give them stable, long-lived identifiers. So we give them machine identifiers that you can use. And you know, we kind of colloquially might say this is kind of like DNS for ideas instead of for IP addresses. There has been a lot of work in this area over the past few decades. Some people have called this consensual reality, which is kind of a grand term. And our take on it is to focus on data that we have and that we can get, and to focus on things which are clearly important, notable people, all the places in the world, products, for example. So how do we represent all this data? Well, we represent it with a thing we call a graph of knowledge. In one dimension, this is just a big list. We have a big list of topics, and we try and make that list as comprehensive as we can. But in another dimension, we have to connect these topics together. We have to say things about them. So we need to know that Arnold Schwarzenegger is the governor of California, or that he's married to the topic called Maria Shriver. And so the way we do this representation is with triples or entuples. And there's a lot of work in this area has been done since the 60s. And the idea keeps coming up again and again and again that if you want to represent knowledge, you should do it with these triples. Or you should do it with tuples generally, and the simplest version that is adequate for what we're doing is triples. So a triple would be a subject, predicate, object. So for example, Arnold would be the subject, Maria would be the object, and the predicate would be is married to. And there's many, many variations of that over the years. So here's a more concrete example. So Alfred Hitchcock directed Rebecca, which starred Laurence Olivier, who was married to Vivien Leigh. Now you can see that very quickly, if you add the rest of the links in the graph, it becomes really hard to represent in a two-dimensional surface like this. So Rebecca also, you know, starred Joan Fontaine, who was presumably married to somebody. And you start drawing all these links, and very quickly you get this mess. But this is the basic core idea, and we just have hundreds of millions of these things. So getting technical again for a minute, this idea has come up many times before. It's probably its first exposition was so-called semantic networks and artificial intelligence. There was a large and well-funded project that ran for almost 20 years, it's still running, called Psych, which actually, incidentally, I believe was spun out of thinking machines back in the day. One of the principal investigators in Psych, R.V. Guha, went off to Apple, where he worked for Alan Kay for a while, and he took the core ideas and turned them into this thing called MCF, the Meta Content Framework, I believe it was called. And those ideas got recodified by him and Tim Bray and submitted to W3C as what's now called RDF. And then W3C did a huge amount of work after that, but that was the basic lineage here. And the basic idea is that in order to represent knowledge, we need a directed labeled multigraph. And that if we have one of those things, it's sufficient to represent, I'm loath to say all of human knowledge, but let's say enough of human knowledge to be interesting, and to be a lot more interesting than the systems we have built today. Interestingly, you can also represent with these graphs the schema, what we would call the schema representation for a database. I explicitly am not using the word ontology here, but some people would say that you could also represent ontology. One notable thing about these graphs, which have been around for several decades, is that as far as we know, they cannot be efficiently implemented in traditional relational database stores, which is a bit of a problem for the current database industry. And there's been some recent work at MIT on so-called column stores, which are the kinds of variants of relational databases that are used for data warehousing, and we don't think they work particularly well either. So basically, you need a new kind of database. You need a graph data store, and we have built one of those. So this is all a little bit of abstract, and in fact, traditionally when this stuff was done, it either sounded grandiose or it sounded somewhat dry and abstract. And one of the things we try and do with Freebase is we try and make it real and sort of grounded on things that everybody would kind of agree it's worth representing. So I'm going to give you some examples just to give you a flavor of what's already in Freebase. So here's a random assortment of towns that are in Tuscany in Italy. Here's a bunch of suspension bridges in the world. Here's a bunch of French actresses born before World War II. These would be represented in Freebase as people who were actresses or had the profession actor and whose birth date was prior to 1939. And I believe they're sorted in birthday order. Characters created by Stan Lee Comics. These are public companies who are in the petrochemical industry, so oil companies. Russian cosmonauts, probably astronauts that are whose nationality is Russian. Candy bars, the kind of thing you don't typically see in these kinds of AI databases. Something more serious, genera of orchids. We have about 100,000 species in Freebase, and we plan to add about 1 million. And these are represented as fully structured objects so that you can go up and down the tree and you can browse the kingdoms of life and so on and so forth. So that's what we mean by a database of knowledge. We mean a complete database of these ideas, of common sense reality. Now, we can't build such a thing. We have a lot of data in Freebase, but we're not, the arbiters of the world's knowledge. So if this can be done, it has to be done as a community thing. People who are experts in Russian rocket engines need to come and work on it. So it has to be a community-built thing. So I'll talk about some of the features around that. So here's a typical user page of Freebase. This is one I picked at random yesterday. Some guy called Metapsych, or maybe it's a woman called Metapsych. And they've been contributing to Freebase since April or so of last year, probably on and off. And they've made 2,400 contributions, and they've found it necessary to add 250 new concepts or common sense ideas, topics. And they've made a bunch of contributions. And as, a day or so ago, they were working on telescopes, and they seem interested in exobiology or exoplanets. So this is a typical sort of user at Freebase. So anybody can edit the database, but it requires attribution. Unlike Wikipedia, where you can make anonymous edits, you have to at least have an account. The edit history is part of the database. The database is an append-only immutable database. So if you add a fact and then somebody else reverts it, then all of that history is there. We found it a little overwhelming to say, well, this is a database of everything. So we've organized it into domains of knowledge, things that people might feel like they want to tackle, like soccer or food or biology. So we have these domains, and I'll show you some examples of these later. And then, very importantly, and unlike other systems, in Freebase, people can contribute to the schema as well as the data. They don't have to work within a fixed schema. The schema can change over time. And then finally, we have a fairly strong access control mechanism, which supports, I would say it's a mechanism that supports a policy. And we don't know what the policy is yet. We're experimenting. So right now, there are some parts of Freebase that are quite locked down because they're core to the functioning of the system. And there are other parts of Freebase which are basically world writable by any logged in user. And we think that will change over time, but we don't quite know how. So we've built a mechanism that will let us experiment with what it means to have access control for data. This idea that users can edit the schema is fairly novel, so I'll take a moment and talk about that. Schema-last, we call it, or the database guys call it, or schema later. And what it means is that as people participate, as they use the data, as they contribute to the data, and as they try and build applications against the data, the requirements for the schema might change over time. Now, in a traditional database environment, you might be aware that what you have to do is set the schema in stone before you can import any data. And you can change the schema, but it's a big deal. You're going to break code if you change the schema, and so on and so forth. And so this idea that the schema is malleable just like the data is fairly radical. The queries that people will make against the data, we have no idea what they are. Traditionally with a database, you figure out what queries you want to make first, and then you set up the indices in the database so that you answer those queries quickly, and then then that's how it works. And so you have rows and tables and columns and B trees and indices which know exactly what they're going to be asked, and if you don't ask the question that they're set up for, then it's known that performance will be bad. We're trying to build a system where we have no idea what people are going to ask, and that we figure it out as they come in and ask. Schema needs something to arbitrate it. So if somebody was going to make a schema or an ontology for books, for example, they would typically go off, and I don't mean with Freebase, I mean in the non-Freebase world, they would typically go off and they would go, sit in a committee meeting and they would decide what are all the things we could possibly ever want to know about books. And they would create a big complicated schema, and they would create all this complexity, and they would say, there we go, and let's standardize that. If we only all use this schema, we'll be great. And there's some of that you can do, but basically we think that if you actually have data that you want to put into a system and you want to represent, that's the moment when the schema gets real. Because do you actually have subject matter for this book? If you do, then great, let's go add it. But the idea of having the schema come last means that you can let the schema be driven by the meritocracy of the data you actually have. And we think it's a very important feature to make tractable progress. Reconciliation is often post hoc. What does that mean? That means that it's actually possible that when you put something into the database, you make a duplicate by mistake. we would prefer that you didn't, but it's possible that you did do that. And then a user coming through would say, oh, you've got two of these things. Please merge them together. And so we have a process for doing that. And then finally, knowledge is accretive. What do I mean by that? Well, if the community comes along and goes to hardly an effort to put in the latitude and longitude of every zip code in America, then that's not going to change. Zip codes very rarely change. Or if somebody puts in the birthday of Arnold Schwarzenegger, that fact will be valid 20 years from now. It's accretive. So Freebase is not really for data which changes very rapidly, like the minute-by-minute tick price of a stock. It's for things like this company is in the carpet manufacturing business. It's for data which changes slowly, stuff that we would normally call knowledge. So here's an example of 70-odd debates that we have in Freebase right now. Things like baseball and film and fictional universes and medicine. And these are sort of common sense areas which are not fixed, but they're places where a community could go and work on something. Visual art is one that's pretty popular right now. There are some in bold here which are more important to us. They're sort of so-called backbone domains. We have like people and businesses and locations. We've done a lot of work at Metaweb to fill out those because we think that they're very important, sort of scaffolding and structure that is going to be used by all of these other things. So let's look at some more examples. All of these queries, by the way, are run in real time against the Freebase API that I'll talk about later. It's like half a page of HTML and JavaScript that is doing all of these queries with some URL args. And they all return in less than a couple hundred milliseconds. So tropical storms, from 1990 to 2000. Films were scored by John Williams, a prolific guy. This is fairly topical. All the pontiffs, I think, in order. Mountains of the Himalayas. Airplanes manufactured by Boeing. I only recently noticed that Air Force One and Enola Gay were both made by Boeing. French cheeses and the art of Caravaggio. Somebody told me recently that in the rather gruesome thing with the beheaded David with Goliath here, that's actually a self-portrait of Caravaggio. The head. He killed somebody and he was very upset with himself. Okay, so I've tried to describe what we think of as database of knowledge, the kinds of stuff we want to put in there, that it must be community built because people have to contribute to it because we can't do this alone. And if it's going to be really community built, it has to be freely available. People are not going to invest their time and effort helping build this thing unless they can get the data and go do with it what they want. So Freebase is very free. That's why it's called Freebase. It's under a Creative Commons CC BY license, which means that it's for commercial use and requires attribution. We want people to come back and correct the data. It has an open API. We have a query language for our graph database that is a little unusual. And it has an open HTTP API. So you can go build an application today on Freebase, and several companies are. And then if you're still not convinced, we take the entire data dump in various formats, and we compress it, and we make it available as a flat file. And it's currently about 500 odd megabytes. So where are we at? We've been working on the software for quite a while, and we've only recently got serious about putting data in Freebase. We have about 130 million we call assertions of fact. So what's an assertion of fact? Arnold is married to Maria. PARC is in Palo Alto. This cheese is made with this milk. This person is the CEO of Apple. Those are an assertion of fact. There's maybe 10 to 15% of those that are sort of system-y stuff, permissions and things like that. So let's just call it, 100 million pieces of knowledge that we have in the system. And our goal is obviously to get 200 million, 400 million. There's about 3.4 million topics. Those are things that you might want to talk about, these common sense things that we talked about before. There's 1,300 published types. There's a few thousand, so that would be something like motorcycle or organism or basketball player. That would be a published type. There are several thousand more that have been created by the community that are not ready for prime time or where people were debugging them. And so we expect that number will go up slowly over time. And then there's the 70 domains, which are sort of organizing domains that we talked about before. So that's a capsule description of what Freebase is. Now the question is, well, what problem are we trying to solve with it? Why do we need this thing? Well, simply put, the web would work better if we all agreed upon a core corpus of identity. What do I mean by identity? Well, identity means being able to have our computers understand these concepts that we all understand. So let's take a word like Jaguar. Well, this representation in hex is pretty much what we have inside of all of our computers. That's all we know about it. We have this sequence of characters, and that's it. That's what our computers have. They don't know very much about it, and that's kind of a problem, because did you mean Jaguar, the car company with its beautiful E-type? Did you mean the animal? Did you mean the 1960s Fender guitar called the Jaguar? You kind of get the point. I won't belabor it, but there are many, many, many different meanings for the word Jaguar. Apple operating system, two completely different military aircraft called the Jaguar, a Brazilian cartoonist called Jaguar that we don't know about, but people in Brazil presumably do. British rocket, superheroines, the whole bit. And Jaguar is not the only word that has this collision problem. Many, many words do, and it's really just a symptom of the larger problem, which is that computers have no representation for common everyday ideas. So our computers have that string, and it's not good enough. We need more. So in the Freebase system, we disambiguate these things. If you type in Jaguar, we're going to give you all of the Jaguars that we know about in order of relevance and importance, and we try and give you an image and a blurb if we have one to help you pick the right one so that you know which one you're talking about. Okay, so why is this important in the larger sense? Well, on the web today, you might come to your web browser and you might be trying to find this newfangled Canon camera, the Digital Rebel. It's a nice camera. And over at DP Review, they have this amazing review about this camera, right? And at eBay, somebody's selling it in this auction. And at Craigslist, some guy in Palo Alto is trying to unload his because he doesn't like it. And at Amazon, they'd love for you to do a one-click buy, but they need you to have this little sort of ASIN thing there to be able to do that. And yet, you know that you're interested in this camera. It's in your head, but you have no way of telling the web that. You interact with these websites, which are user interfaces, renditions of the database that each of those companies has. They have a big database, but inside that database is a record that represents that camera, but the records are not using the same ID. That's a really big problem. So what do? We use search engines. We type in strings into search engines who do the best possible job that we know how to do to give you representative results. And these aren't bad results. The DP review is in here, and people have paid mightily to give you those pixels on the side and the top. But if you look up here, it says there's 386,000 results. It's not the best 368,000 results. You want maybe 20 or 30 results. Even better, you'd like to be able to tell the system that you have the camera and you want to get it repaired, or you're looking for accessories for the camera, or you're looking for the lowest price for the camera, and you want these websites to be able to offer you that service. You want to find the manual for the camera, and it's a product. Every product has a manual and firmware updates, but we don't know that. We just know the string, Canon EOS XSI. But in your head, you know that is what you want. You know exactly which concept you're talking about. And if we had a database that was built around concepts rather than built around strings, we could do something different. We could give you an application that looked a bit more like that. It had cameras in it. It could show you all the Canon cameras. It could show you the camera that's above and below this in the line. It could compare the cameras for you. It could tell you cameras are available fastest. It could do all these things. And websites could be built to do all these things, and some of them are. But they first of all need a list of all the cameras that you might be thinking of. I hear you say, is this the semantic web? 2001, Tim Berners-Lee started marketing this idea of the semantic web, a web that was marked up that was for machines instead of for people. It's an extremely good idea, but it hasn't gone very far. So is Freebase a semantic web company? Well, yes and no. So like the semantic web, we have a graph data model because we think you need one to represent arbitrary knowledge. Like the semantic web, we have identities for things. The semantic web wants to use URIs. We have 3.4 million URIs. And like the semantic web, we're web-based. We interact with the web. You don't have to use some new thing to use this. We try to be as web-friendly as we can. But unlike the semantic web activity, there's a bunch of things we're not doing. We have no first-order logic. Let me explain that. So in the semantic web community, they have taken the graph model idea of RDF, and they have added onto it these ontology languages. The current most popular one called OWL. And OWL is a really impressive thing. It's like many other systems that have been built before it, which basically tries to represent in first-order logic things that you might need to know about the topic. So for example, that men and women marry, except when they don't, or that dogs are a kind of animal. Hierarchy, negation, cardinality, all of these things. All good things, but they basically they require you to write a very complicated ontology before you can get anything done. And they haven't been wildly successful. There's about 4,000 ontologies that people have written, but they kind of violate the thing I was talking about before, which was that you have to write the ontology before you can get started. And we think that the data should drive the schema and not the other way around. So Freebase is a database, and it has a schema. It does not have an ontology. Another important difference between Freebase and the semantic web idea is that we are a writable database. We're a resource on the web that you can write to, and we'll accumulate the facts. The semantic web idea is that everybody will take their existing database, like the ones I was showing you before, like the Craigslist database, and then emit it all as a pile of RDF, and then some future search engine will draw this data in and do something useful. And that's not, it's not a bad idea. We just don't see any evidence of it happening, and so we've decided to make a central resource on the web which has all this data in it, and then give the data away. So I'll take a moment and tell you what Freebase is not. It's not a formal system for knowledge representation, and so that might get a bunch of boos from various directions, but we just decided not to do that because it's too hard and lots of people have done it before. So it's not Psych, it's not Sumo, it's not this new thing called True Knowledge, and it's not Paul Allen's Halo. It doesn't have a reasoning engine in it. It only has data and schema. People sometimes say, is this not Google-based? The difference between Freebase and Google-based is Google-based doesn't have a concept of identity. It doesn't reconcile all the things together. It doesn't have one copy of San Francisco. So this isn't a new idea. People have been trying for a very long time, actually. People often look at the formal logics that we use in artificial intelligence, and they say, well, this all goes back to Leibniz or before. And when I looked into this, I was kind of surprised to see that in the 17th century, when Latin was no longer being used, or was falling out of favor, there was a lot of activity around finding a common language to talk about stuff. And there's a few books, this one which is out of print, like Universal Language Schemes of England and France, 1600 to 1800, a whole book about different languages that people came up with to try and represent knowledge, because it was so important. But when you look into it, so Descartes and Leibniz and Newton were all working on this and all fascinated by this idea, but it turned out that Leibniz had two different ideas. He had one idea which he called an alphabet for human thought, and then he had another idea which there's a lot of controversy about whether this is the same as formal logic, but he had another idea which was that we should be able to reason about that, and we should be able to build machines that reason about those ideas. It's the first idea that we think is interesting or doable, which is let's at least write down all of the ideas that we want to talk about. So if we want to talk about global warming, we have to have some machine representation of the idea of global warming. He had several crazy ideas for doing this. I haven't actually seen a complete language that he came up with. One idea was to use pictograms like Chinese or hieroglyphics. He had another idea of using prime numbers. I'm not quite sure how that would have worked out, and another idea of using fractions. So a little knowledge goes a long way. There's a sort of philosophical objection to this project, which is that what is identity? Can you even agree upon a point source for something? And I think if you're a philosopher, you might conclude that you can't. But that doesn't mean that we shouldn't try and do something at least practical. Alfred North Whitehead said that things are clear. In the focus of experience, there's comparative clarity, but everything else is just kind of a mess. And I was amazed to find this quote from Charles Babbage, which was that errors you make with inadequate data are much less than those you make if you have no data at all. And right now, we basically have no data at all about common sense knowledge in our computer systems. So we live at an interesting time with the internet and with broadband. Over the last 10 years, people's databases, which were previously locked up behind applications, are now becoming more and more available. We are awash in unreconciled data. Wikipedia gets a huge amount of attention in the academic community. Ed's going to give a talk here in a few weeks, who's done some amazing work around Wikipedia. MusicBrainz, WordNet, the SEC, the entire SEC corpus is online and freely available. The Psych project has dumped all their data. There's massive databases of NIH data and medical data and ChefMoz, a free database of restaurants, all kinds of stuff. We're just awash in this stuff. The question is how to make some sense out of it. So I'm going to talk for a few minutes about Wikipedia because that's the easiest to understand large free data set. So Wikipedia has been running for 7 years or so. This is a graph of the total number of articles in Wikipedia. The black line is all of them in all the languages. The red line is English. I'm always amused by this blue line. This kind of straggly blue line here is the Italians, and they seem to kind of go on vacation every summer. It's kind of kind of interesting. So what's interesting about this is a log graph, and what's interesting about it is it's sort of starting to plateau. There's been a lot of discussion about this, about why is it plateauing. It could be plateauing because they're getting kind of heavy-handed about what deserves to be in the encyclopedia. It could be plateauing because most of the stuff that people want to talk about is already there. I mean, they're adding tens of thousands of things a week, but it's not growing as it was several years ago. So an interesting question to ask, so they're up to like 2.3 million topics or something. An interesting question is, how much knowledge is there? How much common sense reality is worth representing? And will we ever get there? Are our machines big enough to hold it all? So digging in a little bit more into Wikipedia, they get currently, as of a couple of weeks ago, they get 2.3 million articles. They get 280,000 of these category things, and there's 7 million things in the category. So a category is something like Albanian poet would be a category in Wikipedia. And so things on average are in more than, in 2 categories or so. Then they have these things called templates. This is a template on the side. I'll talk about this in a minute. So they have about 10,000 templates, 56,000 of these keys. So like, infobox writer influences would be a key. And then they got 42 million values. So they actually have a huge amount of structured, semi-structured data in Wikipedia. And these boxes over here are typed in by hand. People literally edit them in a very basic editor. And so they're saying things here like Kurt Vonnegut was influenced by George Orwell and Joseph Heller, and Douglas Adams was influenced by him. And if they want to do that on the Douglas Adams page, they have to do it all over again and point back to this one. And this data is very dirty. It's very hard to parse. It's socially built. It's full of spelling mistakes. It's terrible, but it's amazing. It's 42 million assertions of fact that our computers could use if only it was put into some normalized form. So here's Kurt Vonnegut, and the kind of thing that you could do that you couldn't do before, which is this is contemporaries of Kurt Vonnegut who went to Cornell with him. And there's Janet Reno, of all people. So in case you think that the only data in Freebase actually came from Wikipedia, this is a different visualization. I'm sorry it's so dark. This is a visualization that Toby Sigrin at Metaweb did. So the orange dots are zip codes. So we have all of the zip codes of the United States in Freebase and all of their latitudes and longitudes. And so he plotted them all on a blank canvas and got the United States. Thank you. And it looks remarkably like one of those pictures of, Earth at night. And the reason for that is that the zip codes are more dense where there's more people because the mail routes are more dense. The white dots are the locations of Walmarts, because we have all the Walmarts in Freebase too. So 1970, that's how many Walmarts there were. And so this is actually a video. I'm not going to play the video because it takes a little long. I'll just walk you through a couple of slides. So 10 years later, there was that many Walmarts. And in 1990, there was that many Walmarts. And you can imagine what happens if I skip all the way to 2007. There's that many Walmarts. It's still kind of interesting, though, that there's more Walmarts in the East Coast, in the East United States than here. But anyway, so this is an example of the kind of visualization that we want people to do with the data in Freebase. The data is all free. It just needs to be put in a form where somebody can drag it out and build something really cool like that. OK, now I'm going to take a little digression here and talk about something different, which is that when we were building Freebase, we took a kind of global perspective, and there's a reason for that. The ITU tells us there's about 1 billion people online, more or less, depends how you define online. So there's probably a couple 100 million internet devices, maybe more, on the planet. And they break down very much along demographic lines. This is a picture of, well, it's sort of a picture of 20 years of the internet growth. It's actually the number of active BGP entries on the net, which means the number of net blocks that are actually able to talk to the global internet. And it's nice because the data goes all the way back to '89. And what's really cool is you can see the .com crash right here. The internet actually shrunk a little bit. But now if you look at it, it's growing exponentially again. It's growing faster than it was. And my contention is that all of that growth is not in North America. It's in emerging markets. So here's data. It's pretty old, from probably 2006. It's the ITU stats. And you can see that North America is just 20% of the world internet users. So it's really important, if we're going to build something that captures the contributions of a community, that it deal with the fact that most of the community is not speaking English, for example. This is a slide I did for a talk I gave last year. And it's a bit of a digression, but I think it's kind of fun. So this the Adam Smith article on Wikipedia is interesting. He's a famous Enlightenment guy from Scotland, so I picked him. And I think I read somewhere that when Warren Buffett gave Bill Gates $31 billion, Bill Gates gave him a gift, and the gift was his personal copy of The Wealth of Nations. So I thought it'd be kind of fun to look at this, and what I did was I took the IP addresses of all the people who contributed to the article over 7 years. It's quite a heavily edited article, and plotted them on the world. And so you can kind of expect that North America was pretty well represented, and so was Europe. But you can also see that people made substantial contributions which have lasted in places like Turkey and Saudi Arabia and Ethiopia and Nepal and China. And I think that's good. I mean, I'd like to see more of it, but I think it's good to realize that social contributed databases have to be global. So in Freebase, what we did was we said that if we're going to have a concept like the Constitution or a constitution, so everybody kind of knows what that means, we better have it in different languages. And so these are all the different language labels for the idea of constitution. System of government codified as a written document. If you want to talk about the greenhouse effect, it's probably pretty useful to know what it's called in Korean if you're going to use this data in machines. Okay, I'm going to end here by showing you some example applications that have been built on top of the Freebase API, just to give you a flavor of what's possible. This is a kind of zoomed in bit of a topic view at freebase.com. Showing the whole thing would kind of make it hard to read. So this is Edward James Olmos, great Oscar-winning actor, and you can see that he is a person and a film director and a film actor, and for each of those facets, each of those types we call them, we have a bunch of data about him, and the data is filled out in the appropriate facet. And there are some empty fields, and you could fill them out, and that's fine. And we have a picture and a blurb and stuff, and it's all machine readable. We can filter things. So we got like 750,000 people, famous people, notable people in Freebase, and we say, okay, well, let's limit them to people who are American or United States citizens and cyclists. And we get a list of American cyclists. And that filtering happens pretty much real time. Here's an application that was built by a guy, Pierre Lindenbaum, in France. He just sent it to us and said, here's what I did. And he did a sort of history of science browser. So there's a timeline here that's interactive, and there's a whole bunch of selection boxes, and you can basically say, find me all the French botanists and how they all relate to each other, and there's influence nodes and all kinds of stuff in here. This is Archie Portal by Zachary Stein. This is a detail of it. It's a sort of big dynamic Ajax app that lets you look at architecture in real time. So here it's displaying the buildings of Norman Foster, and for each on a Google map, and for each one it shows you some data about it. And so it's kind of interesting. Norman Foster is a very famous European architect who's building his first American building at Ground Zero. And then I will show you this other app if I can. Last one here. Yeah, okay, so this is an app we call CineSpin. So if we take a movie and click on it, then it will look in the graph to find all the things that are related to that movie. So these are all the people, and we say, well, what's Russell Crowe been up to? And these are the movies that Russell Crowe did, and so on and so forth. And you can just kind of walk through the graph. And this particular Flash app was designed around movies, but you could equally well do the same thing for VCs and companies and what have you. All these apps are up at freebase.com. Feel free to play with them, and or if you build your own. A bunch of people are, actually. There's a bunch of apps that are being built by various people, and it's quite good to see. All right, so I'm done. I thought I'd leave some time, balance of time, to take your questions. Yes, sir?
Yeah, actually, two questions. First, who are the investors providing your funding? And second is, do you see Freebase as being complementary to PowerSet?
Sure. So the investors who invested in Metaweb Technologies, the company that built this, our initial fund round was led by Benchmark Capital, and our most recent round, late last year, was led by Goldman Sachs and Benchmark and a few others who contributed. Your question was, is this complementary to PowerSet? Yeah, it is. So PowerSet's natural language search actually uses a lot of data from Freebase, so we're very good friends with them, and because the data is Creative Commons SA, they take the data out and use it as part of their categorization system, and they're free to make queries of the Freebase data. So I think it's complementary in the sense that we're trying to build a reified collection of facts about the fact that Edward James Olmos is an actor, and they're doing free text search, which requires that kind of knowledge to be successful. We're not doing free text search at all. Any other questions? Yes, sir.
Well, since your whole ethos here is reconciliation, what tools are you using for scraping Wikipedia and reconciling the data together and checking for contradictions and things like that?
Yeah, so we've built a lot of tools internally to do these kinds of things. It's generally a very hard problem, which boils down to the more you know about something, the better you can do. So if you know that Harrison Ford is an actor, then you can probably find that guy out of all the other Harrison Fords in the world. If you know that he's an actor who starred in the Indiana Jones movie, then you're golden because you've got more bits of disambiguation. So to give you an example, like if you were adding all the Oscars and you wanted to put in Marlon Brando, if you knew that Marlon Brando had starred in On the Waterfront, and you had On the Waterfront in your database already, you would be more likely to find the right one. So in our website where you can type data in, and people do, we use this autocomplete thing that I showed you before, where you type in Jaguar and it shows you this menu, and you pick the right one, and we rely on people to pick the right one or correct them when they're wrong. When we're bulk importing data, we have tools that basically find all the candidates that are likely, and more importantly, find the candidates which we don't know are likely.
So the point is that Harrison Ford also happens to be a carpenter.
Yes.
And that's something that you can discover, potentially, because you already know he's an actor, presumably, in your database.
Yes.
But on the other hand, your point is that the key issue is disambiguation. You have no great clues on how to do that other than prompting people for the ambiguous points and saying, please pick one, I guess.
Yes, and really, it all starts with being willing to say we should only have that guy once. Because if you give up on that and you end up with multiple Harrison Fords, then you've basically got the same problem we have today, which is that the web is deeply denormalized, and therefore you can't talk about anything.
Second question I have is I used to do configuration management, and identity winds up being a big issue. And one of the things in particular with your cameras is you kind of come to the conclusion in one implementation of that is, in fact, all cameras are different. They aren't all, so in particular, there's the BMW, there's models of BMW, there's my BMW,
That's right.
and my BMW goes on and has a flat tire, which distinguishes it from your BMW with exactly the same
That's right, and
model.
your BMW has a specific VIN number, right. So that would then not be a model of camera, that would be a particular product. There's a gentleman who's modeling motorcycles in Freebase, and he has in fact left a space in the schema for modeling my motorcycle, which is an instance of this particular edition of this particular model, right? And there are many things that are like, I don't know, the Porsche 911 has been built for years and years and years, and every year is different, but it's really all still the same model. So we have all these semantic modeling things. Books have editions, as does the music. And really it comes back to this question about the meritocracy of the data. If you have the data, then sure, go nuts and model the specific editions of books, right? But if you don't have the data, then it's probably good enough to say, BMW, whatever.
The other issue you come up with is basically are modeling errors. That is, whether you're a meta type or whether you're an instance of a type, or what, all the stuff pretty much I got wrong when I wound up trying to do this stuff.
Right. Well, this is why I made the comments about schema-last. The schema model changes over time as people kind of figure this stuff out. And every time I see people load data and then go, oh, I needed a different part of the schema. The other thing is that we've explicitly stayed away from very heavyweight computer science ideas like inheritance, because they're just too tricky when you're dealing with human knowledge. We don't even do type inheritance. It's explicitly done. You assert that canonical example is like all actors are people. Well, that's what the ontologies would say. Well, except unless you're Lassie, right? Or Benji the Wonderdog, in which case you're not.
Very practical.
Yeah.
What is it that comes with scaling this up? Is there some phase transition, something that occurs suddenly, or could you study this whole phenomenon or this whole method on small scale, or does it require this expansive scale to discover things about how things would work?
Right. Yeah, it's a good question. The question is how big is this going to get, I think is kind of the bottom line of that question. How does it big does it have to be? So it's kind of interesting that all the Wikipedias after 7 years are basically, 10 million pages, and actually they fit on a pen drive. So we live in an interesting world where you can put, the biggest encyclopedia that's ever been written in your pocket. It's hard to say. It depends what this turns out to be useful for. If it's useful for looking at French cheeses, it's not a problem. If it ends up being necessary to look at every position in every company in the world, then the database will need to get really big. The database will get bigger. The technology is getting better all the time. Basically, we rely very heavily on 64-bit machines. So if we tried to do this 5 years ago, I don't think we could have done it. Our bet is basically that it will get as big as it needs to get, and it depends how useful it is. But that certainly already there's enough human knowledge in here to be able to do things that we couldn't previously do. This gentleman had his hand up for a while.
Are you beginning to see cultural differences emerging? Because the whole way that Chinese culture categorizes things, French culture categorizes things, American, they're different. So that's the first question. The second question is, if I put Freebase into this, would crack cocaine come up?
Yeah, sure. I'll answer the second question first. So yes, so there's two generations of people in the world, those who know what Freebase used to mean and everybody else who needs to go look it up. We called it Freebase because it's a free database and it's a catchy name and we liked it and it stuck. Your first question is about cultural bias. Now, I think cultural bias exists independently of language. If you look at something like Wikipedia, like the English Wikipedia or the French Wikipedia, it contains a great Western geek bias, right? There's lots of computer video games in there. There's lots of, there's lots of films in there, and there's lots of fictional work in there. It's whatever people chose to put in. What we've tried to do with the type system in Freebase is let you model things different ways at no penalty. And in fact, what we already see in amongst the several thousand types that people have created is that some people want organism classification and other people want animal. People want the colloquial thing or they want the strict scientific thing, and they debate it, right? And there are people from the semantic web community who are using Freebase who are trying to put ontologies in there. And there are people from the archaeology and museum antiquities groups in places like Greece who have very strong ideas about how they want to model their museum artifacts in a system like this because they've been doing it in committee work for years. So our approach is basically to be very naive and say, we don't know what's going to work and what's going to be practically useful for people, but we're not trying to make one size fits all. And I think that the problem with things like Psych is that they really did sort of start from the assumption that we are going to model person correctly, and a person is an actor is a sub-instance of person and so on and so forth. And they had 6,000 micro-theories, which was fragile because it didn't reflect the ebb and flow of people debating things. Now, with respect to other languages, we have been very careful to put all these language labels in there because we think that if somebody's going to fill out the director of a Jet Li movie in Shanghai, that's a valid fact that you would want to see in German. And so sort of generally with this project, we sort of shy away from the hard problems that would scare us because it's worth doing the simple thing. And I think that for many, many years, people have, when they've tried to tackle this, including back in the 17th century, what they did was they immediately got caught up on, like, this is impossible. And maybe it is impossible, but that doesn't mean that we can't collect together many millions of reconciled facts that are useful.
One of the things that comes to mind about cultural differences immediately, since I'm the family chef and do a lot of cooking, is that looking at food from a Chinese point of view, and looking at food from an Italian point of view, and from a French point of view, and from an English point of view, are like in different universes?
Yes. But, well, can you give me an example?
Butchery.
A great deal of Chinese cuisine is aimed at treating and curing a variety of health conditions.
Sure.
At the same time that they taste good.
Yes.
On the other hand, English food is just the reverse.
Okay.
It's creating conditions at the same time tasting bad.
So an interesting question would be, can you model such a thing with a system like this? I mean, you could certainly take the organism called seahorse and say the Chinese dry it and use it to cure this disease, right? I mean, you could certainly model that, but whether you could capture all this cultural nuance, I don't know. But the alternative is to not try and to just be able to have to type in strings all the time, and that seems too limiting. The man at the very back.
Yeah, I have two questions. One is basically how do you attract users, and what's your strategy behind getting users to come and use this, and what incentives you have? And the second is, what's your business model?
Okay. So the question was, how do we attract people to this? And then the second was, what's the business model? So the way we attract people to this is just by making it as open and available as we can. We try and document what we're doing. We come give talks like this. We have example applications like the ones that I showed you. It's very early days for us, but people are sort of showing up anyway. The internet is a very different place now than perhaps it was 5, 6, 7 years ago. If people find this useful because it's open and the barrier is so low, they'll come and use it. And we have evidence of people who are building large commercial things on this because we've been helping them. And so we're pretty happy that people are showing up. Now, you know, are we going to go evangelize all the, I don't know, antiquity librarians of the world to use this? You must use this? No, I think it's going to be much more of a sort of pool. Like, what will be very interesting is to see what people find it useful for. With respect to a business model, I'm going to say a little bit, and then I'm going to say that we have a bunch of products that require this corpus that we haven't released yet. So basically, we believe that people, when they're looking for stuff, need help. That the current model for finding everything about your Model 2 TiVo is kind of badly broken, and that there's a better way to do that. And whether we do it or we partner with people who are doing it, and there's a business there. But it requires that this corpus get critical mass in the first place. And so we're when we started the company, we were very focused on building the new software we needed to do this, and now we're very focused on like populating the data and helping people come and help. And we have a bunch of really exciting products I can't talk about that will be out later this year. It depends who uses it for what purpose. So the API, the terms of service for the API is you may use this for free up to sort of Amazon scale, 100,000 API calls a day. If you want to build an application on top of this that's wildly successful, you need to come and talk to us. So that wouldn't be an advertising model, but we reserve the right to build, you know, things on top of this that might be advertising supported. It's very early for us right now. Right now we're just trying to get people to understand what we're doing and trying to get critical mass behind the data. Yes, sir?
You said that the graph of knowledge cannot be implemented effectively in an RDBMS or a column store.
Yes.
What are you using as the back end?
So we built our own graph database store. There are a number of academic graph, so-called RDF graph stores, which are pretty good. There's a blog posting on our site, blog.freebase.com, that actually, from our chief database guy, that kind of explains what we're doing in a little bit of detail. The problem with with relational databases is you have to know the schema ahead of time, and you only have B trees. And Mike Stoneybreaker, who's quite a famous database guy, has written extensively about this and about MapReduce and about how it may be time for something new, and we agree.
My question is your system available for people to play around with?
It's available as a web API. So we have a proprietary backend database that drives all this, and you can take the data out with the API, or you can take the flat files out and go put them in your MySQL database if you want. But our graph database is not open source. No, it's proprietary. Yes.
Could you say a little bit more back to how to present ambiguity here? Because people have very conflicting things that they believe are facts.
Sure. Well, give me an example so we can talk about it.
Well, any of the ones that run Armenian genocide, for example, is one that lots of people disagree with.
How about Obama's opinion of Hillary and Hillary's opinion of Obama?
Okay, so opinion and argumentation can be represented in a system like this. It's a very deeply philosophical problem, and there are people who know a lot about it in Cambridge University and other places who are playing around with Freebase. However, while this is a great example of, well, we're not sure we could represent argumentation sufficiently that everybody would agree about us, so we'll just collapse in a heap. But we could at least agree that some people believe in something called the Armenian genocide, and so we should at least have a topic for it. Now, if you want to create a type that says falsehoods of the Western imperial something, and co-type it privately, go knock yourself out, right? We think there's enough consensual reality that it can at least be put there. Now, we haven't had yet our first edit wars around religion, but I'm sure they're coming. But we try to basically represent what is agreed upon as knowledge, which is not essentially the same thing as the details of opinion about knowledge. So the existence of a place, for example, is not very controversial, right? And if you come in and you try and delete Palo Alto because you don't want it to exist, you're going to lose and eventually going to get your account locked out because that's just silly. But if you want to come in and you want to model Hillary Clinton's opinions, you better get yourself set up for a big citation war because you're going to attract a whole bunch of people who disagree with you. This is a great example of where people haven't tried to do this because the easy stuff, they immediately go to the hard stuff and forget that the easy stuff is extremely valuable and just hasn't been done. Where's Kosovo? Actually, one of the fascinating things that we found out when we were putting some data into the system was that there isn't one set of countries in the world. I was blown away by this. I always thought, well, we can at least agree upon all the countries at a certain time in the world. This is not a temporal database, by the way, so it's intended to represent now, and if you want to represent historical countries, you need to put them in under historical countries. So it turns out that in the Olympics, they have their own country codes. And you're like, why do they have their own country codes? And it was because there were Olympic Games where East Germany played, but it was no longer a country. Same with FIFA. And so we modeled all of this stuff in there, and we have all the foreign keys, so if you really want the Olympic country code for Kosovo, it'll be in here.
Well, if someone says Bush is president, and the next person says Bush is not president, how does that manifest some
If
contradictions.
somebody typed Bush as, current president of the United States and somebody deleted it, that person would be in trouble because it is true.
Somebody else was the current president. I mean,
Well, that's simply not true. So, I mean, it's kind of like Wikipedia. I mean, there has to be some general mob rule about what is reality.
yeah, I want to know how that works.
Well, so the way it works is every edit to the database is done by a logged-in user, and the history of all the edits is available on every topic page, and any change can be reverted. So it's post hoc moderation like Wikipedia, but with a slightly stronger thing. If somebody comes in and spams the entire database, because it's a database, we can revert everything by that user in a certain time period because it's a structured data source. So, we have tools that do some of that. Yes.
Is it community moderation, or is it people working in Freebase?
It's mostly community moderation and a combination. So the change logs are available as RSS feeds. There are people at Freebase who look for mass changes. It's intended to be a shared community thing where the processes will emerge, we hope.
How do you deal with situations such as the border between India and Pakistan, where you would get 100,000 people saying each way?
Yes. Well, I'm going to create a topic called disputed border area and let people
Or the land
annotate
area
that.
of India, which is supposed to be an indisputable fact, but depending on whether you ask an Indian or a Pakistani, you'll get different responses.
Sure. Well, then you might end up having to model the UN accepted border region, and then you can write lots of comments on it saying you disagree with the UN. I mean, the trick is not to try and have reality correct. The trick is to provide a tool where people can at least attempt to write down reality. Yes, sir.
So one of the things you mentioned is that Freebase is not a reasoner.
Yes.
So, for instance, like how would you find out that there was some kind of contradiction, or is that just up to the users to figure out?
Yeah, so we explicitly decided not to build a formal knowledge representation system. So formal knowledge representation systems can't cope with ambiguity, and they're also fragile. Freebase is explicitly designed to let you say that Bush is president and not president at the same time. And that's because in some spectrum from the free text web searched by statistical search engines to the psych system, which has a whole bunch of self-consistent microtheories and can reason about show me a picture of happiness, is a famous demo they did. The Wikipedia is like, this large amount of hand-edited, unstructured text. We want to be one step more machine-readable and queryable than the Wikipedia, and a long way away from a formal ontology.
Maybe we can take one more question.
Yes.
Yes, sir.
So what I heard was that the business model is somewhat in flux, certainly not proven, have yet to reach critical mass. How did you convince two of the top drawer investors, benchmark gold, to put a bunch of money into it? What's the magic?
The honest answer to that question is because this only needs to be done once. And somebody's going to do it. And maybe we will get it wrong. I've worked at several companies where we've been too early. But this is going to happen. Somebody has to do this because otherwise, as the web corpus gets bigger and bigger and bigger, our ability to find things will get less and less and less. And the reality is that people are in small communities that care deeply about the things they care about. My friends who are into digital camera lenses are really into digital camera lenses. And right now, the web doesn't give them any help, any tool, other than go set up your own website with yet more HTML. So at a very broad level, our machines need to start understanding the concepts that we care about, and it has to get done. And people have taken several goes at it, including in the 17th century, and whoever gets it right will profit.
Okay,
Thank you
very much.